Okay, so in the last section we had instantiated balls and they were sitting over near the starting grid. And what I've done this time, and you might be able to pick it up, is that I've made it so that the labels that appear above the balls always face the camera. So on the ball prefab, that's just a matter of adding this. Sorry, I'll go to the ball prefab and the ball label. Um, you have UI facing script on there, and what that does is it basically, once it's identified the camera to look at, it always looks at the camera by this simple little two-line thing here. So that's a really neat trick that we'll use a couple more times. But basically it means that if we were to fly around this now, we would find that no matter where we go, those numbers are always looking straight at us. So that's quite nice. Now the other thing that we've put on the ball is a thing called drag object. Now what drag object does is it allows us to drag with our mouse the balls, and they'll always just stay on the same y-axis, but they'll move around on the x and z-axis. And you'll notice quite an interesting thing. When I bang into another ball, it gives them rotational motion, which is quite nice. You'll notice as well that the numbers, the canvas on top sort of goes haywire. So that's something that we'll want to fix in a minute, because we'll actually want to switch that off while they're moving. So drag object is a really nice script, and again it's a pretty simple one. This is it here. I just copied it off somewhere on the web. I can't remember exactly where I got it from, but basically it allows you to drag on the X, to convert an XY drag with the mouse into an XZ drag on the 3D Unity gameplay. So that's a couple of things with the ball, the drag object. The other thing is this one here, uncapped physics speeds. The reason why this is there is that it basically allows the angular velocity of the ball, or of the rigid body on the ball, to not be limited. One of the things that I learnt when I was looking at sort of ball rolling, golf type games, was that for some reason it's better to not put a limit on the angular velocity of the balls. Things just work a bit better. I don't know why that is, but that's the case. So those are the three extra scripts that we added. Now, the next thing that we did was to put in a target. Now, this is a target prefab. As you can see, it's a very simple item. It's essentially just this is really a blank object. I know it's a sphere and everything, but I've got the mesh renderer turned off. I do have a collider on there, and that's just so I can grab it, and that's why the drag object script is on there as well. So once this is in the game, then we'll be able to drag the target around using our mouse. Later on, there's a better way of moving the target, but that will do for the moment. And then there's just this stalk and there's a flat graphic on the bottom, which is just this target graphic. So this is just a picture. It's just a sprite showing a target, because that seems logical to aim at. And the cylinder here is just sticking up just to make it easier to see where it is in 3 dimensions. but the cylinder doesn't have any collider on it, because we don't want the ball to bang into it and be influenced by it. So that's a target that we're always going to be shooting the balls at. So in order to instantiate that, I've put it on the setup menu. So we've got the target prefab as a prefab, and then at the start we're going to put out the target, which basically means just instantiating this target at some sensible place. The height that it's instantiated at is just to be a sort of sensible height. And in fact, I might alter that. I think 0.03 is a better number, but you know, and then just give it a name. So now when we do our start, we'll be putting out the target, but you'll notice that we're doing something else on start as well. We're making a reference to a new script that we made called Stroke Manager. Now I'll go into that in a moment, but first of all I'll show you that indeed we did instantiate the target, and we did put it at 5 - 3. This is actually a good opportunity for me to see just what the Y should be. Obviously we want that target showing, so it's going to be about there. So 0.025 would probably be a better option for the height for instantiating the target. So I might actually make that change now. So what we're going to do is always fire the ball at the target. Now, which ball we want to fire is going to change. There's 10 balls. I'm just going to start by assuming it's the red number 1 ball, which is ball 0 in our list of balls. And we're going to fire it when we hit this stroke button. So we're going to have a script to do that, and the script is going to be called the Stroke Manager. Now there are 2 things that we need in this Stroke Manager. The first is we need to know where the target is, so we need a reference to the target. So we have a game object target, and that target is set, will be set by this little function here. Now you might think, well, we could do that at the start, but in fact you can't, because this has to run after the target has been created in the setup script. There's probably some fancy way of making the setup script run first and then making this run, but it was easier just to call it from the setup script. So this set objects function is just called from the setup script after we've created the striker, the balls and the target. And then we're going to make the striker ball number 0 in the list of balls. Now clearly that's going to change every time we want to play with a different ball, but it'll be good enough to start with now. Now what will trigger our shot is clicking the button stroke, which will activate this function here, and that will turn strike from false into true. So we've got a Boolean, which is basically just saying whenever you see strike being true, do this fixed update routine here. Now, what we're basically doing is asking Unity to say, where is the striker? Where is the target? How far is it between them? And what angle is there between them? So to find the distance between the 2 things, we find out the target position and the striker position. And remember, we just want the X and the Z coordinates. We don't want to know the height difference. If we start getting into the messy business of height differences, the ball might go up into the air or be hit into the ground. So we're just looking to play a shot which is going level. So we're only wanting the X and the Z. So we can work out the target position of the position of the target by creating a vector 2 of the X and the Z coordinates, similar for the striker ball, and then we just use the inbuilt Unity function vector 2 distance to actually tell us what the distance is between those two X and Z positions. Now there is a function as well that will do this for angles, but I have to tell you that I have not been successful at getting this to work, because I think that what happens is that it starts to take into account the Y differences, and you get it just goes crazy. So I've just gone for ordinary trigonometry and just said that the angle of the shot is the difference between, is the tangent of the difference between the X position of the two things and the Z position of the two things. And once you've got that angle in angle, you convert it to radians, and then you work out the X and the Z components of what you want based on the sine and the cosine times the total distance. So this is just basic trigonometry. I might draw a picture of it at some stage. Now, if we were to just put that into this last line, which is applying a force to the rigid body of the ball, if we were to just do that, then we'd find that the ball would go really, really hard. It would be, the force on the ball would send it going miles. So what I've done is I've done a lot of work to try and find out what is the ideal fiddle factor, the little tweak factor, to put on the force to get the ball to go exactly to the target. And as part of that, there is also these things that you can put on the ball and the lawn, which are applied to the colliders of the two things. So on the sphere collider of the ball, there's this physics material called ball properties. On the lawn, there's a physics material called lawn properties. And those physics materials are held here. So ball properties has this dynamic friction, static friction, bounciness, same with the lawn. And I've just fiddled around with those and fiddled around with this conversion factor here to get something that will send the ball the right distance. So let's see that in operation. So let's hit play, and we will let's go and have a look at our balls over here. So here are the balls. Now remember, the striker ball has automatically been set to ball 0. So the striker ball is, when we press this stroke button, it's the ball number 1, or ball 0 on the list of balls in the setup, is the ball that's going to move. So with a bit of luck, it will move to this target here. Now, because I've got the drag thing on the target, I can just move that around. So hopefully when I hit stroke, that ball will go diddly 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 dee, and it will land pretty much exactly on the target. And if I move the target to there, it goes stroke, then the ball comes to a stop on the target. If I move the target all the way up here, right up into the corner, go back again, and then hit stroke, then let's see, it pretty much lands on the target. So you can see that the combination of these friction, dynamic, static for both the ball and the lawn, and then the little fiddle factor that I've put in here, they are nicely tuned to get the ball to go exactly to the target, pretty much any length of shot that you play. And believe me, that took me a long time to do. There may be a much, much cleaner, better way of doing that. Actually, look, I've just noticed here that the target is a little bit low there, isn't it? It's a little bit low. Let's bring it up to 0.27. That will be better, I think. Yeah. So even if I just play a short shot like this, the ball rolls nicely onto the target. If I take this target all the way down 20 meters down to the end of the lawn and then play the shot. Then the ball ends up absolutely spot on the target. So it's very, very good. But look, there may be a better way of doing the frictions and the fiddle factor that turns the distance between the target and the ball into a force, which when applied to this rigid body will take it exactly the distance that you want. All right, so that's it. What we're going to do next time is look to see how we can make different balls the striker ball. We'll also take off this rather annoying thing where the label rotates, and we might start as well to make a better way of seeing the position of everything, but like a mini map, so that we don't have to keep flying around the lawn to do it. Good.